Assalamualaikum and hi students. So let's start our tutorial class, first hour week 1 with subtopic 1.1 reaction rate. So today we are going to learn about differential rate equation, or in bahasa Melayu persamaan pembeza kadar. Right, so firstly what you must know is what is reaction rate. What is the definition of reaction rate? Reaction rate is the changes in concentration of reactants or products as a function of time. And the reaction rate describes how fast the concentration of reactants, concentration of products changes per unit time. Basically, you have already learned in the previous lesson, when a reaction occurs, let's say I have A converted to B. A is the reactant and B is the product. So, once the reaction starts, what happened to the concentration of reactant A? The concentration of reactant A decreases over the time. And for concentration of B, it will increase as time goes by. Alright, so if I sketch a graph, right? If I sketch a graph, concentration of A against time. So in this case, we will focus to the reactant. The concentration of A will decrease as time goes by. And if we focus to the concentration of product B and we sketch the graph, what graph? Concentration of B against time. The concentration of product or concentration of B will increase as time goes by. If we combine this graph, you will get a curve like this. This is a graph or curve concentration against time. So this is the concentration of reactant A and this is the concentration of product B. So that is the basic concept about what happened to the concentration and as time goes by during the reaction. Alright? Okay, so now let's focus to the main topic here. How to calculate rate of reaction. So you have already learned previously during SPM level, right? How to calculate rate of reaction. So basically rate, right? Rate is the changes in concentration of reactant divided by the changes in time, alright, or changes in concentration of product divided by the changes in time. So delta T here is time. Alright? Okay. So now, if the unit of concentration is molar, if the unit of concentration is molar and the time is measured in second, let's say the time is measured in second, right? So during reaction, when a reaction occurs, we can measure the time in terms of second, minute, hour, or maybe years for radioactive, for example. Okay, let's say the time is measured in second. So the unit of rate is molar per second, right? Okay, so this is the important thing that you must know before we go further. Okay, let's say I have a rate of reaction. Let's say I have a rate of reaction of A. So please refer here. 0.2 molar per second. So what does it mean? Okay, so it shows that the concentration of A decrease sebanyak berapa? So the concentration of A decrease 0.2 molar in 1 second. Dalam masa 1 saat, berapa kadar pengurangan A? Kenapa saya kata A? Sebab A kat sini adalah reactant. So A berkurang sebanyak 0.2 molar dalam masa 1 saat. So that is what is meant by rate of reaction. Okay, so now let's focus to the main point here, or main topic. Okay, differential rate equation is differential rate equation. It shows the relationship between the rate of disappearance of reactants and rate of formation of product. So dia menunjukkan kadar pengurangan reactant dan juga dia hubungkan, dia relate dengan kadar pembentukan produk. Alright. For example, let's say I have A converted to B. So, what is the relationship between the rate of disappearance of A and rate of formation of B? So, we can use differential rate equation to relate the rates. Alright? Okay, so basically how to write the differential rate equation? Rate, you must start with rate equals to negative. Why you have to put negative here? Because the concentration of reactant will decrease as time goes by. D, right? D, it shows that differential concentration of A over dt, and it is equals to positive. The positive sign is compulsory for products. Positive, it shows that the concentration of product increases as time goes by, equals to positive D concentration of B over dt. Alright, and since here 1 mole and 1 mole, so kita boleh tulis macam ni lah, right? But if I have 2 mole of A converted to 3 mole of B. Alright? Okay. So how to write the differential rate equation? So differential rate equation is rate, mesti start dengan rate, equals to negative 1 over 2. The concentration of A over dt equals to positive 1 over 3 D concentration of B over dt. Alright. Itu cara nak tulis differential rate equation. So nanti kita akan belajar apa kaitan rate antara rate dengan produk tu dengan lebih detail. Alright, so now look at the next example. Okay, I hope you can refer to the worksheet given in Telegram groups. And saya pun dah post dalam GC. Jadi saya harap pelajar boleh refer soalan-soalan itu, dan sepatutnya pelajar buat dulu. Jadi bila pelajar tonton video ni, dia tak adalah tenganga ke apa. Dia boleh refer apa yang sedang dibincangkan. Alright? Alright, so example 1. I have this reaction. 1 mole of hydrogen gas reacts with 1 mole of iodine gas, produces 2 mole of hydrogen iodide gas. Okay, from the balance equation, we can see that for every of hydrogen gas that is used up, 1 mole of iodine is also used up. Okay, tengok kat sini. Bagi setiap 1 mole of hydrogen gas yang digunakan, berapa mole iodine yang digunakan? Juga sebanyak 1 mole. So itu yang dibincangkan sekarang ni. Okay, so kalau kita relate in terms of stoichiometry, itu maksudnya in terms of stoichiometry relationship. Okay, for every molecule of hydrogen gas, if we relate with if we relate with the mole of hydrogen iodide form. So you can see here, for every molecule of hydrogen gas that is used up, 2 mole of hydrogen iodide are formed. Itu hubungan stoichiometry. Alright, so now how to write the differential rate equation for this reaction? You must start with rate. Rate equals to negative, since here is 1 mole, so tak perlu tulis 1 mole kat sini, terus D concentration of hydrogen gas. It is compulsory untuk ganti reactant dan produk yang sebenar, sebab dia dah berikan awak balance chemical equation. Over dt equals to, kita relate dengan iodine, negative D concentration of iodine over dt, and equals to positive 1 over 2 the concentration of hydrogen iodide gas over dt. Okay, so this is how to write the differential rate equation for a chemical reaction. Alright, next. Okay, so this is the differential rate equation for the given reaction tadi. Okay, so now apa yang kita boleh interpret daripada relationship ini? Okay, kalau saya nak hubungkan, kalau saya nak hubungkan dua rate ini, maksudnya sekali ini adalah dia punya chemical equation. Kalaulah ditanya apakah kaitan rate of disappearance of hydrogen gas dengan rate of disappearance of iodine gas, so kita refer kat sini. Jadi sekarang kalau kita lihat kat sini, untuk rate, kalau kita nak tengok rate dia antara hydrogen gas dengan iodine gas adalah ini. Okay, sini soalan ni belum ada lagi nilai. Maksudnya sekarang the rate of disappearance of hydrogen gas is same with the rate of disappearance of iodine gas. Itu maksudnya. Okay, sekarang saya nak relate pula rate of disappearance of hydrogen gas with the rate of formation of iodine gas. Jadi kalau macam tu kita relate dua, rate of disappearance of hydrogen gas, saya nak relate dengan rate of formation of hydrogen gas. Kadar pengurangan hydrogen gas nak dikaitkan dengan kadar pembentukan hydrogen iodide. Okay, jadi kalau you tengok kat sini, we know that rate, kita relate dua, kita refer kepada differential rate equation itu, negative D concentration of hydrogen gas over dt equals to positive 1 over 2 D concentration of hydrogen iodide gas over dt. Okay, apa maksudnya? Maksudnya kat sini adalah the rate of this appearance of hydrogen gas is half from the rate of formation of hydrogen iodide gas. Okay, maksudnya sekarang negatif kat sini kita merujuk bahawa ini adalah kadar pengurangan bagi sesuatu reaktan. Jadi reaktan kita adalah apa? Hydrogen gas. So negatif kat sini menunjukkan kadar pengurangan bagi hydrogen gas. Okay, positif di sini menunjukkan kita tahu bahawa concentration of product will increase. Jadi positif kat sini merujuk kepada produk. So kadar pembentukan produk adalah positif berapa? Kita tengok kat sini. Jadinya sekarang kalau awak tengok kat sini, okey. Yang ini ni, yang saya kotakkan ini, okey, yang saya kotakkan ni. Okey. Inilah yang dipanggil rate. Rate. Jadi, saya boleh, maksudnya sekarang, kadar pengurangan itu, kalau bagi reaktan, dia mesti ada sign negatif. Jadi, ini negatif tu menunjuk kepada kadar pengurangan, dia merujuk kepada reaktan. Jadi, berapakah rate of disappearance of reaktan? Reaktan mana? Hydrogen gas. Ini sebutannya dalam bentuk differential rate equation. So, yang positif kat sini merujuk kepada produk. Apa produk kita? Bagi contoh ini, hydrogen iodide. Jadi, yang saya circle ke saya apa benda ni, ini adalah rate of the formation. Ini adalah rate of disappearance. Okey, jadi apa hubungannya? Kalau kita lihat di sini, rate of disappearance of hydrogen gas, kadar pengurangan hydrogen gas adalah separuh daripada kadar rate of formation of hydrogen iodide. Itu satu contoh. Okey, kita tengok contoh yang lain. Okey, sekarang saya nak relate, masih lagi saya gunakan contoh hydrogen gas dengan hydrogen iodide gas. So, please refer to the relationship between the rate of these species. So, kalau saya relate, saya hubungkan rate of disappearance of hydrogen gas dengan rate of disappearance of hydrogen, kalau saya hubungkan rate of disappearance of hydrogen gas dengan rate of formation of hydrogen iodide gas, so inilah tadi dia punya differential rate equation, where rate equals to negatif. Sebab apa? Hydrogen adalah reactant. The concentration of hydrogen gas over dt equals to positive, sebab hydrogen iodide adalah produk, equals to positive half the concentration of hydrogen iodide gas over dt. Alright? Okay. So now, kalaulah saya tanya, berapakah kadar pembentukan, what is the rate, by using this relationship, what is the rate of formation of hydrogen iodide gas? So you tengok kat sini, dia bagi dua hubungan ni. Tapi dia tanya, berapakah kadar pembentukan hydrogen iodide gas kalau kita bandingkan dengan rate of disappearance of hydrogen gas. Okay, so kalau you tengok kat sini, kalau saya baca yang ini, kalau saya baca apa yang saya tulis ini saya maksudnya apa yang saya boleh interpret, apa yang saya boleh terjemahkan, rate of disappearance of hydrogen gas is half from the rate of formation of hydrogen iodide gas. Tapi saya bukan nak tengok rate of disappearance of hydrogen. Saya tadi tanya, berapakah, what is the rate of formation of hydrogen iodide gas kalau kita compare, if we compare with the rate of disappearance of hydrogen gas. So jawapannya apa? It is equals to, saya boleh tulis macam ni, 2 times of the rate of disappearance of hydrogen gas. Jadi, kalau awak lihat kat sini, ini ni yang ada positif ini yang saya kurungkan ini adalah rate of formation of hydrogen iodide. Yang ini saya kurungkan ini adalah rate of disappearance of hydrogen gas. Jadi apa hubungan rate of formation of hydrogen iodide gas dengan rate of disappearance of hydrogen gas? Rate of formation of hydrogen iodide gas is twice, 2 kali ganda of the rate of disappearance of hydrogen gas. Jadi itu konsep asas yang perlu pelajar faham. Alright, okay. So now look at example 2. Masih lagi contoh umum. Okay, the first question, the question asks you to write the differential rate equation for the above reaction. Okay, for question 1, you have to refer to the balanced chemical equation because we need to relate with the stoichiometrical, we need to relate to the coefficient in the balanced chemical equation. So, rate mesti start dengan perkataan rate. Rate equals to, since A is the reactant, equals to negative 1/2 the concentration of A over dt, and it is equals to positive. Kenapa positif? Sebab B adalah produk positif. The concentration of B over dt. So kalau you tak tulis perkataan rate kat depan ni, bila kita tulis rate differential rate equation, dia salah, tak diterima ya. Okay, question number 2. Which rate is higher? The rate of disappearance of A or rate of formation of B? 1/2 the concentration of A over dt is equals to positive the concentration of B over dt. Baik. So sekarang, kalau saya tulis begini. Okay. Sebab dia tanya, rate disappearance of A yang higher or rate of formation of B yang lagi tinggi. Jadi kita kena tengok relationship itu, berapa kali ganda tu. Okay, jadi katakanlah yang ni saya pindahkan. Saya tukar macam ni. Therefore, negative the concentration of A over dt is equals to 1/2 ni darab silang ke sini. Equals to what? You tengok kat sini. 2 times concentration of dB over dt. Bila kita tengok kepada balance equation, B ini adalah produk, A adalah reactant. Jadi kalau kita tengok kat sini, rate of formation of rate of disappearance of A, kadar pengurangan A adalah 2 kali ganda daripada kadar pembentukan B. Because yang dalam kurungan tu saya dah ajar tadi, itu adalah rate. Cuma kat depan ni ada 2 ni menunjukkan kadar rate of formation of B 2 kali ganda. Okay, kalau saya buat pula maksudnya saya tulis rate of formation of B berapa kali ganda kalau kita compare dengan rate of disappearance of A. It is equals to, okay, depan tu 1/2 kan. Saya boleh juga tulis macam ni, 1/2 darab negative the concentration of A over dt. Jadi ini adalah, yang dalam kurungan ini adalah apa? Rate of disappearance of A. Jadi kadar rate of formation of B adalah separuh daripada kadar rate of formation of B adalah half, separuh daripada rate of disappearance of A, while rate of disappearance of A adalah 2 kali ganda daripada rate of formation of B. Okey, jadi apa kesimpulannya? So kita boleh tulis kat sini. Kita tulis dulu baru kita jawab. Okey, untuk yang sebelah sini ni, the rate of disappearance of A is 2 times of the rate of formation of B. Right. For this part, rate of formation of B is half from the rate of disappearance of A. Jadi apakah jawapannya? Plus the rate of disappearance of A is higher compared to the formation of B. Maksudnya pengurangan A itu berlaku lebih cepat berbanding kadar pembentukan B. So in terms of time taken, dari segi masa, time taken for disappearance of A is shorter. Maksudnya A itu berkurang dengan kadar masa yang lebih cepat berbanding pembentukan B. Maksudnya B mengambil masa yang lebih lama sedikit untuk terhasil berbanding pengurangan A. Okay? Itu masih lagi konsep asas. Okay, so now look at the last example for this video. Okay, ammonia burns in oxygen to form nitrogen oxide, NO, and water. Right? So, given to you a balanced chemical equation. So, the question asks you, write the differential rate equation for the reaction. Baik, since the differential rate equation relates the rate of disappearance of reactants and rate of formation of product, maka bila kita nak tulis differential rate equation ini, kita kena hubungkan daripada reactant sampai ke produk. For question 1, you must start with rate. Mesti tulis perkataan rate. Tak tulis, saya kata salah. Equals to negative 1/4 the concentration of ammonia. Tengok kurungan yang digunakan, it is square bracket, over dt equals to negative 1/5 the concentration of O2, oxygen gas, over dt equals to positive 1/4 the concentration of nitric oxide ataupun nitrogen oxide, over dt equals to positive 1/6 the concentration of water vapor, over dt. So please bear in mind, tolong berhati-hati dengan sign negatif and sign positif, wajib dituliskan. Okay? Okay, next. At particular moment, the rate at which of oxygen disappear is 0.40 molar per second. Calculate the rate of disappearance of ammonia and calculate the rate at which water form. Okay kelas, so how to solve these problems? Okay, macam mana kita nak selesaikan soalan B? Soalan B masih lagi asasnya kita kena refer kepada differential rate equation yang kita baru saja tulis dalam soalan A. Okay, tengok soalan masing-masing. Okay, given the rate of disappearance of oxygen gas is 0.40 molar per second. So, kalau saya terjemahkan terms ini ke dalam bentuk differential rate equation, maksudnya apa? the rate of disappearance of oxygen gas is 0.40 molar per second. So ini saya terjemahkan dalam bentuk differential equation jadi ini. Okey. Baik. Itu maklumat yang diberikan dalam soalan. So, soalan pertama dia tanya, berapakah rate of disappearance of ammonia? Jadi, dia tanya pula, berapakah rate of disappearance of ammonia? So, kalau saya tulis dalam bentuk differential, dia jadi macam ni. So, apa kita nak buat? We are going to relate the rate of disappearance of oxygen gas with rate of disappearance of ammonia. So by referring to the differential rate equation, okay, so saya jadikan oksigen tu kat depan. The rate of disappearance of oxygen gas, so kalau saya tulis kat sini, adalah negative 1/5 d concentration of oxygen gas over dt, which is equals to negative 1/4 d concentration of ammonia over dt. Okay, nampak? But since the rate of disappearance of oxygen gas over dt is 0.40 molar per second. Mana dapat? Ini dalam pilih soalan. Maksudnya apa? Maksudnya ini adalah sebutan bagi ini. Maksudnya saya boleh buat macam ni. Okay, saya boleh buat macam ni Okay, ini adalah sebutan bagi inilah, bagi oksigen. Tadi saya salah tunjuk. Bagi oksigen. So, maksudnya saya boleh buat macam ni. 1/5 negative D oxygen gas over dt is equal to 1/4 negative D concentration of ammonia over dt. Ingat yang dalam kurungan ni itu adalah sebutan bagi rate dalam bentuk differential rate equation. Okey, tapi soalan tanya berapakah rate of disappearance of ammonia. So maksudnya sekarang kalau saya nak cari rate of disappearance of ammonia, apa saya perlu buat? Saya perlu darabkan ini ke sini. Nampak? Which is equals to 4/5 times the rate of disappearance of oxygen gas. So, the rate of disappearance of ammonia is equals to 4/5 darabkan dengan ini, nilainya 0.40 molar per second. 0.40 molar per second. So, bila you selesaikan macam biasa. Guna matematik. Tekanlah kalkulator. Thus, the rate of disappearance of ammonia over dt is 0.32 molar per second. Mesti ada unit, dan unit tak nilai rate tak boleh negatif. Jadi sebab itu saya ajar cara macam ni. Sebab kalau you buat negatif kat depan, contoh you tulis macam ni. Okay, saya tulis saya buat macam ni lah. Okay, contoh saya buat macam ni. Awak buat macam ni. Ramai ini yang silap yang warna biru ni yang biasanya ramai pelajar silap. So dia buat macam ni. negative D concentration of ammonia over dt equals to negative 1/5. Negative 4/5 D concentration of oxygen over dt. Lepas tu dia pun gantikan negatif 4/5 darab 0.40 molar per second. So dia pun selesaikan, dia tulis negatif 0.32 molar per second. So ini salah sebab rate tak boleh negatif. Negatif kat sini merujuk kepada kadar pengurangan bagi sesuatu reaktan. Sebab reaktan itu adalah berkurang concentrationnya terhadap masa. Jadi yang ini yang betul. Yang ini yang betul. Negatif tu pada sebutan dalam bentuk differential tu. Okey. Baik, saya harap video ni membantu. Awak semak, sepatutnya awak dah buat. Dan saya nak awak submit soalan number 4 dalam worksheet tu through GC dan juga soalan face to face. Buat dan submit di GC juga. Sebelum bila? Sebelum kelas tamat.